Hello students, welcome back to the 8th video of this playlist. In this video, we will be solving question number 8 from the recent past paper of Pure Mathematics 1, which is the October 2023 P1 paper. So let's get started with question number 8. Okay. The curve C1 has equation xy equals to 15 over 2 minus 5x where x not equals to 0. The curve C2 has equation y equals to x cubed negative 7 over 2x negative 5. So two curves C1 and C2, their equations are given. Fine. So part A, here it's asking to show that C1 and C2 meet when 2x to the power 4 negative 7x squared negative 15 equals 0. Okay, so when the curve C1 and C2 will meet each other, what would be the case? Their y coordinates and the x coordinates would be equal at the point of intersection. Okay, so in this equation we can see that they have eliminated y, so that's what we will do also. So at first, from the equation of curve C1, let's make what the subject? Y the subject. So y would be equals to 15 over twice x negative 5x. So at the point of intersection, their y values would be equal, so we will eliminate y, so we will get x cube negative 7 over 2x negative 7 over 2x negative 5 equals 15 over twice x negative 5x. So now multiply both sides by x to get x to the power 4 negative 7 over 2x squared negative 5x equals to 15 over 2 negative 5x squared. Okay, now take all the terms on the left side, x to the power 5, so negative 7 over 2 plus 5, so that would give you negative 3.5 plus 5, it will give plus 1.5, negative 3.5 plus, okay, negative 1.5 x squared negative, we got negative 5x there, negative 5x, and then negative 15 over 2 equals to 0. Okay, so they didn't get, okay, they got negative 15. Oh, okay, so it would be 15 over twice of x negative 5, just negative 5. Yeah, it would be just negative 5. Okay, 15 over 2x negative 5. So if you multiply both sides by x, you will get negative 5x. That's why. Okay, so here negative 5x cancels out from both sides, right? So you will have just negative 15 over 2 equals to 0. Now multiply both sides by 2 to get the equation given in the question. So negative 15 equals to 0. X to the power 4 plus 3x squared negative 15 equals to 0. Okay, if you multiply by 2, it will become 2x to the power 4, exactly. So 2x to the power 4 plus 3x squared, okay, it should be negative 7 over 2x squared. Okay, so okay, the problem is here, many things has been changed, so I didn't consider that. So negative 7 over 2x squared, it will be negative, as you multiply by 2, it will become negative 7x squared. Now is it perfect? Right? 2x to the power 4 negative 7x squared negative 15 equals to 0. That's it. Fine. Okay, next is part B. In part B, the question says, given that C1 and C2 meet at points P and Q. So part B is asking to find using algebra the exact distance PQ. So we need to find out the distance between the 2 points of intersection, that is point P and Q. So to find out the exact distance between P and Q, we need to figure out the coordinates of point P and Q. Okay, so to find out the coordinates of point P and Q, we need to solve the derived quadratic equation. So let's solve this derived quadratic equation. So how can we solve this? Let's do middle term. 2x to the power 4. So 2 times 15, it is what? 30. So 10 times 3, it is 30. So negative 10x squared plus 3x squared negative 15. This is equals 0. So we can take 2x squared common. So you will have x squared negative 5. And then you can take plus 3 common from the last two terms. So x squared negative 5 will be there, equals to 0. So here we can see that one of the factors it is giving undefined value, because x squared equals to negative 3 over 2. It's not possible. Square of a number, it is always positive. So ignore this factor. So x squared equals to 5. So x equals to plus minus square root of 5. Okay, now we got the x coordinates of the 2 points P and Q. We need to now figure out the y coordinates. Okay, so at P, let's say at P, x equals to square root of 5. So what would be the y coordinate? Y coordinate would be 15. Okay, let's consider this equation. 15 over twice of x negative 5. So 15 over twice of x negative 5. Okay, so it will be y equals to 15 over 2 square root of 5 minus 5. Fine. So now rationalize the denominator. If you do rationalize the denominator, what you will get? Y equals to 15 square root of 5, multiply top and bottom by square root of 5. So 2 times 5, it will give you 10 minus 5. Okay, so the value for y, it is 3 over 2 square root of 5 negative 5. So this is the y coordinate of point P. Fine. Okay, so we got the coordinates of point P. It is square root of 5, and y coordinate is 3 over 2 square root of 5 negative 5. Okay, now at Q, the remaining x coordinate is negative square root of 5. So the y coordinate would be 15 over negative 2 square root of 5 negative 5. So multiply the numerator and the denominator by square root of 5. So you will get negative 15 square root of 5 over 10. So the y coordinate would be negative 3 over 2 square root of 5 negative 5. So the coordinates of point Q, it's negative square root of 5, the x coordinate, and the y coordinate is negative 3 over 2 square root of 5 negative 5. Okay, so the x coordinate, we got the coordinates of point P and the coordinates of point Q. Now we can find out the distance of PQ. So distance of PQ, it is square root of y2 minus y1 whole squared. So y2 is what? Y2 is negative 3 over 2 square root of 5 negative 5. This is y2 minus y1. Y1 is negative 3 over 2 square root of 5, 3 over 2 square root of 5, and negative 3 over 2 square root of 5, and negative 5. So that would give positive 5. Positive 5 whole squared plus x2 minus x1 whole squared. x2 is negative square root of 5 x1 is square root of 5. So negative square root of 5, negative square root of 5, it will give negative 2 square root of 5 whole squared. Okay, now just simplify the part within the square root. So you will get negative 3 over 2, negative 3 over 2, that would give you negative 3 square root of 5 whole squared plus negative 2 squared is 4. 4 times 5, it is 20. So that would give you square root of 9 times 5, it is 45 plus 20. So PQ, the distance of PQ, we got square root of 65, that much. Okay, so distance PQ, distance PQ is how much? Square root of 65 units. That's it. That's what part B of question number 8 has asked for. Fine.